Alright, so we are now diving into Kitchoff's law as we've rightly stated. So, in Kitchoff's law, there are two basic laws. We have KCL, that's the Kitchoff's current law, and we have the KVL, that's Kitchoff's voltage law. So, we'll first look at the Kitchoff's current law. Kitchoff's current law states that the algebraic sum of currents in a node is equal to 0. Let me repeat again. The algebraic sum of currents in a node is equal to 0. It can also be stated that sum of incoming currents, incoming like this I1 now is incoming currents, is equal to sum of outgoing currents. The sum of those coming in, like I1 coming in now and then I3 coming in, are all equal to the sum of outgoing currents. That's I4 and I2. Those are the outgoing currents. So this is what basically KCL is talking about. The algebraic sum of currents in node is equal to 0. So as you can see from this diagram here, I1 flows through the node, flows towards the node. This is the node at the center. The I1 current flows towards it and is considered a positive current. Positive current, I positive, I1 is now positive. Secondly, I2 is flowing from the node, outwardly from the node, hence I2 is considered a negative current. As we can see, I3 is also flowing inwardly towards the node, is now considered a positive current. I3 is positive, and subsequently I4 is flowing from the node outwardly. That means I4 is now considered as a negative current, I4. So applying KCL on this node, what can we have? Remember, the law states that the algebraic sum of currents flowing in is equal to the sum of currents going out. So we can say I1 now is coming in is positive I1, minus I2 is outgoing, so it will be minus I2. I3 is going inward, would be plus I3. I4 is going out, would be minus I4, all equal to 0. So what do we have? We're taking those going inward at the same side. That's I1 plus I3 is equal to I2 plus I4. This is basically what KCL is all talking about. So having done that, I want us to dive very quickly into KVL, Kitchoff's voltage law, KVL, and this states that the sum of the voltages in a closed, remember closed, in a closed part, but I'd like to say in a closed loop, is 0. The sum of voltages in a closed loop is equal to 0. In an electric circuit, there will be a closed part called loops. They are always present there, and KVL is applied. When KVL is applied to the closed part, only the loop will consist of the voltage source. You understand what I'm saying? Only the loop will consist of the voltage source, the resistors, and the inductors. So in a closed loop, there will be a voltage rise and a voltage drop. In a closed loop, there will be a voltage rise and a voltage drop. This voltage rise and voltage drop depends on the direction traced in the loop. So it is important to understand the sign convention and the direction in which KVL is applied, either clockwise or anti-clockwise. So let's now look at the sign convention before we talk about the clockwise and the anti-clockwise movement. Let's say sign conventions. So A, this is minus, this is positive, always remember. V, this is I now. This is R, let's say this is B. Alright, let's consider this battery source V here, battery source V here, which is in figure A. The battery source now is marked with both positive and negative sign. So when we move from the positive sign to the negative sign, we are having a voltage drop. When you move from the positive side to the negative side, we have a voltage drop. Let me write it down. When we move from positive sign to negative sign, it's called voltage drop. And in the same manner, when we move from negative sign to a positive sign, it's called voltage rise. When you move from positive to negative, it's called voltage drop. When you move from negative to positive, it's called voltage rise. So the same thing happens in the other direction. So when KVL is applied in a clockwise direction, that means clockwise, we say clockwise this way, clockwise this way, it indicates a voltage rise. When it's moved in this direction counterclockwise, clockwise, this is what? Anticlockwise. This is clockwise, this is anticlockwise. When it's moved like this, we experience a voltage rise. It's gone this way, we experience a voltage drop. So I hope you have understood the message I'm trying to pass there. Alright, having done that, we now understood the sign conventions. I believe so. Let's now dive deeper. Find the branch currents and voltages by applying KVL. So pardon me, I'm so tired and I'm feeling so weak and sick today. We'll just treat this topic, just this example, and then I will drop subsequent videos about this KCL and how to go about solving them. So having seen this, what do we do now? What do we do? Remember voltage rise and voltage drop. So let's go into solution. I'll still use this particular diagram. I'll say our current I flowing in here this way. Remember, this is positive, this is negative, so always positive starting here, negative drop. This is I1 flowing this way. This example, let me complete this so that we start solving. This is I2, this is what positive here, this is positive here, this is negative here, and this is negative here. So here this is 10 ohms. Let's call this C, D, E, F, A, and B. So how do we go about solving it? Let's first consider loop A, B, E, and F, and apply KVL in clockwise direction. We're going clockwise, we're going clockwise, we're going this way. Clockwise direction, we're going this way. So going this way means what? Voltage rise would be what? 100 minus voltage drop would be 5i 5 multiplied by I will be 5 minus 6. We are considering this loop. 6 voltage drop, remember from positive to negative is voltage drop, minus 6i1 is equal to 0. But remember I is equals to I1 plus I1 plus I2 plus I2. So having not known that, we would now have 100 minus 5 open bracket I1 plus I2 minus 6 I1 is equal to 0. So 100 minus 5 I1 plus 5 I2 minus 6 I1 is equal to 0. So what do we have here? What we have here is I1 and I1 would be negative, right? Would be minus 5 I1 minus 6 I1 plus 5 I2 is equal to what? Is equal plus 100. We have another 100 plus 100 is equal to 0. Right, that's what we have. That's what we're having. So what else? Okay, these are negative. Let's remember this will cancel with the negative sign. Would cancel with a negative sign. Positive negative would be negative. So what do we do next? Minus 5 I1 6 I1 would be minus 11 I1 minus 5 I2 plus 100 is equal to 0. So here would have 100 is equal to 11 I1 plus 5 I2. Equation 1. Let's call this our equation 1 now, as you can see. So we do not have much space here. We have finished the first loop. This is for the first loop. Now we would go into the second loop. We will now go into the second loop. Consider loop B, C, D, E, B, and apply KVL in clockwise direction. So we're applying it in clockwise direction this way, remember. Okay, what do we have? We would start from this place, from B. Start from B. Remember, from B to this side we're experiencing a drop, so it will be minus 10. It will be minus 10 I2 minus, remember, 8 also is a voltage drop, as it starts positive and ends negative. So voltage drop 8 I2 plus what? 6 is voltage rise from negative to positive. 6 I1 is equals to 0. So what do we have here? Minus 10 I2 minus 8 I2 minus 18 I be minus 18 I2 plus 6 I1 is equal to 0. So 6 I1 is equals to 18 I2. Equation 2. This is our equation 2 now. but we can break it down as well. Divide both sides by 6. You can say over 6, this by this by 6. So we can have I1 is equal to 3 I2. This is our equation 2. So what do we do next? What we would do next is we would substitute equation 2, that's I1, into equation 1, which we have solved previously. If you have noted that down, you can concur with me. I1 into equation 1. So equation 1 was giving us what was our equation 1? If you can remember, if I can remember vividly, our equation 1 was 11 I1 plus 5 I2 is equals to 100. So substituting equation 2, that's I1, into equation 1 would be 11 now. For I1 would be 3 I2. I1 was, equation 2 was I1 is equals to 3 I2, right, plus 5 I2 is equals to 100. So we have 33 I2 plus 5 I2 is equals to 100. So we have 38 I2 is equals to 100. We have I2 is equals to what? 100 over 38. I2 is now equals to 2.68 amps. So no, 2.63. Yes, this is it. This is right. Sorry, I made a mistake. So having done that, we've now obtained our I2. So having obtained our I2, we'll now plug it back into equation 2. Now we would have, we've got an I2, we're now looking for I1. So I1 is equals to 3. I2 is what? 2.63. I1 is equal to 7.89 amps, right? So our total current now would be equal to I1 plus I2. I is equal to, I1 is equal to 7.89 plus 2.63. I total now will be equal to 10.52 amperes. So this is our final answer, but we were asked to calculate voltage across those resistors. Am I right? We were asked to calculate voltages across those resistors. So for all of those resistors, we will calculate the voltage across each one of them. Let's now say voltage across 5 ohms is equal to, remember, we have our current, total current, as where total I capital was equal to 10.52 amps, and now we have I1 was equal to 6. No, I1 was equal to 7.89 amps, and I2 was equal to 2.63 amps. So having put that in mind, we'll now have 5. Remember, V is equals to IR. Remember, V is equals to IR. So voltage across 5 ohms will be what? 5 times the current, 5 times I, which is equals to 5 times what? Capital I will be because the current flowing there was the capital I. If you can see, if you can go back a bit, you can see that across that 5 ohm resistor the capital I was flowing in, so it has to be the capital I, which is 10.52, which our answer now would be giving us what? 52.6 volts. So voltage now across 6 ohms is equal to what? V equals to IR. V is equal to I was given our I, which I was going across 6 ohms, I believe is I1, so it will be I1 times 6. I1 times 6. V now is equals to I1 now, it was given us 7.89 times 6, which is equal to 47.34 volts. That is that. Now voltage across 10 ohms resistor is equals to V equals to IR, which I are we having? We're now having I2 R. V is equals to I2 is giving us what? I2 is giving us 2.63 times R is what? 10, which is equal to 26.3 volts. So the last but not the least, we have voltage across 8 ohms is equal to V equals to IR. V is equals to I2 is still flowing across 8. Sorry for that. V is equal to 8 2.63 times 8. V is equal to 21.04 volts. Alright, that's that for today. As you can see, I'm tired, and even my gadget is tired, so we would meet in our next session where we'll discuss KCL more explicitly and more deeply. So I just wanted to touch it today before we dive in more deeper into the topic. Thank you. Please do not forget to subscribe to this YouTube channel, as we will be dropping more content as this. Thank you so much.